Good day, Mathlets. I'm Alfred Villamor, a former grade 10 student of Antipolo National High School, and today we are going to explore one of the most popular sequences in mathematics, the arithmetic sequence.
To begin, let us first take a look at these four sequences. Which one do you think is an example of arithmetic sequence? To check if your answer is correct, let us first define arithmetic sequence. An arithmetic sequence, also called arithmetic progression, is a sequence where every term after the first is obtained by adding a constant called the common difference. Now, let's go back to these given sequences. If you chose set A as an example of arithmetic sequence, you got it. Set A is an example of arithmetic sequence, set B is an example of geometric sequence, set C is an example of harmonic sequence, while set D is the Fibonacci sequence. But how do we determine whether the given sequence is arithmetic or not? Take note of this. A sequence is arithmetic if the differences between consecutive terms are the same or constant. This constant is called the common difference. Take note also that any number in the sequence is called a term. In the sequence 1, 3, 5, 7, 9, 1 is the first term, 3 is the second term, 5 is the third term, 7 is the fourth term, and 9 is the fifth term. And 1 and 3 are consecutive terms, same with 3 and 5, 5 and 7, 7 and 9. So let's subtract any of the two consecutive terms from right to left. 3 minus 1 equals 2, 5 minus 3 equals 2, 7 minus 5 equals 2, and 9 minus 7 equals 2. We could see that the common difference of this sequence is 2, which is the same or constant. Therefore, the sequence 1, 3, 5, 7, 9 is an arithmetic sequence. Now, let us determine whether the given sequence is arithmetic or not. Is the sequence negative 2, 3, 8, 11, 14 an arithmetic sequence? The answer is no, it is not arithmetic, because it doesn't have the common difference. How about the sequence negative 6, negative 2, 2, 6, 10? The answer is yes, it is arithmetic, because of 4 as its common difference. Let's go back to this arithmetic sequence. Since we already know that the common difference of this arithmetic sequence is 2, can you find the next three terms of this arithmetic sequence? Did you get 11, 13, and 15? That's correct. These three dots called an ellipsis indicate that the sequence is to be continued infinitely or without an end. Suppose you want to find the 20th, 40th, and 80th terms of this arithmetic sequence. How do you easily get them? Do you think a formula would help? If so, we could find a formula for the nth term of the sequence. If first term and common difference are known, it is easy to find any term in an arithmetic sequence using the rule. A sub n equals a sub 1 plus quantity n minus 1 times d. In plain English, this is nth term equals first term plus quantity number of terms minus 1 times the common difference. Example, what is the 20th term of the arithmetic sequence 1, 3, 5, 7, 9, and so on? To find the 20th term of this arithmetic sequence, the first thing we need to do is to identify the variables. So the a sub 1 or the first term in the arithmetic sequence 1, 3, 5, 7, 9 is 1, and the common difference is 2. Now, let's have the formula a sub n equals a sub 1 plus quantity n minus 1 times d. The next step is to substitute these values to the given formula. A sub 20 or 20th term equals substitute 1 in the place of a sub 1, plus quantity 20. Since we are looking for the 20th term of the sequence, that means we have 20 terms in the sequence, minus 1 times the common difference 2, equals 1 plus 20 minus 1 equals 19 times 2 equals 1 plus 19 times 2 equals 38, and 1 plus 38 equals 39. Therefore, the 20th term of the arithmetic sequence 13579 is 39. Let's check if the answer is correct. If the sequence is to be continued, we would obtain 39 as the 20th term of the sequence, so the answer is correct. Another example, find the 12th term of the arithmetic sequence with first term is 6 and common difference is negative 4. Again, the first thing we need to do is to identify the variables. Since a sub 1 or the first term equals 6 and common difference equals negative 4, then 12th term equals, substitute 6 in the place of a sub 1, plus quantity 12, since we are looking for the 12th term, minus 1 times the common difference, negative 4, equals 6 plus 12 minus 1 equals 11 times negative 4 equals 6 plus 11 times negative 4 equals negative 44, and 6 plus negative 44 equals negative 38. Therefore, the 12th term of this arithmetic sequence is negative 38. Let's check if the answer is correct. If we generate the sequence using 6 as the first term and negative 4 as the common difference, we would obtain negative 38 as the 12th term of the sequence, so the answer is correct. This time, I'll give you exercises. Don't worry, it's so easy. You may pause this video after each question and play it again once you're done answering. What is the 20th term of the arithmetic sequence? Negative 8, negative 3, 2, and so on. The answer is 87. The 20th term of the sequence is 87. Did you get the correct answer? Very good. Exercise number 2. Find the 11th term of the arithmetic sequence, with first term is negative 5 and common difference is negative 6. The answer is negative 65. The 11th term of the sequence is negative 65. Do we have the same answer? Excellent. The essence of mathematics is not to make simple things complicated, but to make complicated things simple.